Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 18, Exercise A and B. Before we start, those who are interested in enrolling for my online test series or online lectures, email me or message me on Instagram. Check the details and the description for more information. Now in exercise 18A, we are going to do sums 1, 2, 4, 6, 7, 8.1, 9.1, 11th and 12th. Mark the 11th and the 12th sums as IMP and also the 6th sum. The remaining sums are for homework. The first sum. It's a theory question. State which of the variables are continuous and which are discrete. Continuous variables are those which can take any value in the given range. There are literally infinite possibilities for these variables. Whereas discrete means that there are a fixed number of values which the variables can take in a given data range. So that's finite. For example, number of children in your class. Well, we can have one child in a class, or 10 children, or 50 children, or 49 children, or 17 children. We can't have 17.1 children or 17.9 children. So, since there are some restrictions here, there are limited number of values which this variable can take, so it is discrete. Next, distance traveled by a car. Now, theoretically speaking, the answer for the distance can be any of the infinite values available. You may say 40.5 kilometers, or 40.51 kilometers, or 40.501 kilometers, and we can go on giving a more and more accurate answer. So theoretically this is a continuous variable. Sizes of shoes, well, that has discrete values, fixed values. When you go to a shop, you can have a size 10 or a size 9 or a size 8. You can't have size 8.12. Time, again, theoretically it's continuous. We can have 4 minutes, or 4 minutes 5 seconds, or 4 minutes 5 seconds and 12 nanoseconds, milliseconds, picoseconds. It just goes on. There are infinite possibilities for the time variable, so it is continuous. Number of patients in a hospital is definitely discrete because it has a limited number of options in a data range. So these are the answers. Now in question 2, we have to make a frequency table, and we'll be using tally marks here. So this is the answer, the solution for question 2. I've written the marks here, which was already given in the question. We have the tally marks and the frequency, which we get by counting the tally marks. But how do we note the tally marks? Now, let's imagine that we've got these numbers. This is the data range, and we have a group of 1 to 10, and then 11 to 20, and so on. So what we need to do is we need to use a pencil, and in the question paper we would strike 8, and in this group of 1 to 10 we will write 1 tally mark. Then we strike 17 and 1 tally mark in the group 11 to 20. Then I'm going to go for the next line now, but you should go in order. 9, again a second tally. 18, again here a second tally. And this goes on. You may have a third tally, fourth tally, and for the fifth one just bunch it together. Then the sixth one, seventh one, and once you stop, then it's easy to count because this bunch is 5 plus 2 is 7. So there are 7 tally marks here, so the frequency is 7, and here the frequency is 2. So that's how, after solving the sum, I got these tally marks, and these are the frequencies. So 5 plus 1 is 6. If you total them, it will be 30, which is what was mentioned in the question as well. So make sure you always check the total. But just getting the right total is not a guarantee that your frequencies are correct. You may have accidentally put one tally mark instead of here. You may have put it here, so it will become 7 out here and 5 here. Still your total will be correct, but when we check the frequencies, it's wrong, and you would lose a lot of marks. So be very careful about these tally marks. Now, if you look at these class intervals, they are called class intervals. They are not continuous. For example, if there was a number, say 10.5, I can see that in the question there are no decimal numbers. But what if there was a 10.5? In which class interval would you place it? This one or this one? Well, in either. 10.5 doesn't belong to either of them. That's a disadvantage of such discontinuous class intervals. In such a case, we would have made it continuous. How? That I'll tell you later. Another possibility is, what if in the question it was 1 to 10, and then it was 10 to 20, and then 20 to 30, and so on? What if they would have given the class intervals like this? In fact, if it is left to us to decide the class intervals, we should always have continuous class intervals. But hey, this should be 0, because the class width or the class size should be constant everywhere. What is 20 minus 10? 10. 30 minus 20? 10. So the class width or class size should be the same. If I write 1 here, then 10 minus 1 is 9. So that's not consistent. So it won't be right. So if I write 0 to 10, 10 to 20, and so on, and if there is a number in the data called 10, then in which class interval should I mention it? 0 to 10 or 10 to 20? Well, go for the higher class interval, 10 to 20. So remember, when I say 0 to 10, 0 is included but 10 is excluded. Similarly here, 10 is included but 20 is excluded, because 20 would go to the next one. Next, let's go for the fill in the blanks. A quantity which can vary from one individual to another is called a variable. Sizes of shoes are discrete variables. Daily temperature is a continuous variable, because we can theoretically go on giving a very accurate measurement. If it's 35 degrees Celsius, I can say 35.1 degrees Celsius, or 35.01 degrees Celsius, or 35.001 degrees Celsius. There's no limit to it. Practically all that limits it is the device being used. But theoretically, we can have infinite number of possibilities for the temperature variable. Next, the D question, the range of the data they have asked. Range of the data is nothing but the difference between the highest and the lowest values. So the biggest value is 25, the smallest is 6. So what's the difference between them? It's 19. So the answer is 19. No units are given, so that's the answer. Now in the E question, in the class interval 35 to 46, what is the lower limit and what is the upper limit? Well, obviously 35 is lower limit and 46 is the upper limit. You wish such questions come in the exam, isn't it? Well, it won't. Next, the class mark of the class interval, this. Class mark means the midpoint. You can say the average of these two limits. 22 plus 29 upon 2 gives me 25.5. So that is called the class mark. So we need to know this theory because it helps us to solve the numericals better. So don't ignore them. These are the answers of the fill in the blanks. No need to copy the whole question, just write the answers. Now in the sixth sum, they have asked for the actual class limits and also the class marks. The class intervals that they have given are not continuous. It's 1.1 to 2 and then directly from 2.1 to 3. What if I give you a number, let's say 2.09? In which class interval will that belong? That's a problem. So let's convert this into a continuous class interval, and that way we can get the actual lower and upper class limits also. So this is the table we have to make. These are the class intervals already given, and these are the continuous class intervals. But how do we figure it out? Well, if you see here, the upper limit is 2 and here the lower limit is 2.1. So you can take the average of the two, that is 2 plus 2.1 upon 2, that's 4.1 upon 2, that's 2.05. So that will be the number here and here. Alternatively, just look at the difference between the two. 2 and 2.1, the difference is of 0.1. Halve it. Halve the difference, you get 0.05. This is called the adjustment value. So you always decrease the lower limit by this adjustment value and you increase the upper limit by this adjustment value. That means 1.1 minus 0.05 will give you 1.05, and then 2.0 plus 0.05 will give you 2.05. Similarly, 2.1 from this subtract it, you get 2.05, and so on. Or if you don't want to calculate it with the adjustment value, just do it intuitively. You can just feel that what is the number between 3 and 3.1? It's 3.05. So obviously it's going to be 2.05 to 3.05 and so on. Now be careful about one thing. The class width or the class size should be consistent. What is 2.05 minus 1.05? It is 1. Similarly, the difference here and here should also be exactly 1. And now we can know the actual lower class limit and the actual upper class limit. These are the lower limits and the upper limits when they talk about the actual class intervals, because actual means in continuous class intervals. What about class mark? Well, I told you all you have to do is take the midpoint of the two, take the average of the two. So 1.05 plus 2.05 is 3.1, and 3.1 divided by 2 will give you 1.55. Interestingly, if instead of you taking these values, what if we find the class mark of these? Well, the answer will be same. Also, what is the difference between two class marks? It is the same as the class size always. It is 1, and even here the class size or the difference between the lower and upper limits was 1. So keep these points in mind while solving such sums. Next, in the seventh sum, the actual class limits of the fourth class. Well, we've got the fourth class here, but you can see that it is not a continuous class intervals, and they've asked for the actual class limit, so we'll have to convert it into a continuous class interval. So 45, 44, 45, what is the midpoint between them? 44.5. so this will become 44.5 decreased by 0.5, and 49, 50, what is the average of them? 49.5, so increase this by 0.5. So the actual class intervals are, or class limits are, 44.5 to 49.5. Next, the class boundaries of the sixth class. So again, we'll have to give the actual class boundaries. So this will become 54.5 to 59.5. That's the only way this will be a continuous data. Next, what is the class mark of the third class? 1, 2, 3. You can either use the actual class intervals or you can use this one as well, because class mark answer or the midpoint answer is always the same. So it's 40 plus 44, that is 84 upon 2, that's 42. Next, delta, the upper and lower limits of the fifth class. They have not used the word actual upper and lower limits. So we can directly write the answer here. The lower limit is 50 and the upper limit is 54. Next, what is the size of the third class? Again, to find the size, don't use these data. We have to use the actual class limits. So the actual class limit of the third class was 39.5 to 44.5. And what's the difference between them? 5. So these are the answers. Now in question 8.1, the class interval and the frequency is given and we have to make a cumulative frequency distribution table. How do we find this cumulative frequency or CF? As the name suggests, cumulative frequency is nothing but the addition of frequencies. Cumulative means keep on adding. So we start with the top, we just copy the top frequency as it is always. This is called of the less than type. This is the only type in your syllabus, so just follow these instructions. Next we do 13 plus 9, that becomes 22. Then 12 plus 22, that becomes 34. 7 plus 34 is 41 and 15 plus 41 is 56. And if you total these frequencies, it will also be 56. So the total of frequencies and the final cumulative frequency should be the same. What is the use of cumulative frequency? Well, we'll study that in a bit. Let's go to the next sum, 9.1, which is the reverse of 8.1. In 9.1, they have given the class intervals and the CF, and of course CF always increases. It can never decrease in less than type. So that's a big difference between frequencies and cumulative frequencies, because frequencies can increase or decrease, it's random looking at the table, but cumulative frequency always increases. And this last cumulative frequency is actually the total of all the frequencies. But how will we know the individual frequencies of each class interval? Well, in the previous sum we had added the frequencies at every step to get the cumulative frequency. Here we'll do the opposite. Step number 1, copy the first number as it is. That's always the case. Next, do 19 minus 8, that is 11. 23 minus 19. Understand that there is no diagonal operation to do. Here there was a diagonal operation to do, but here just it's the upper number minus the lower number minus the upper number. That is the bigger number minus the smaller number. 23 minus 19 is 4. 30 minus 23 is 7. If you add all these frequencies, can you guess what will be the answer? It will be 30, the final cumulative frequency. Now in the 11th sum, they have not given the class interval ready-made. They've just given the ages below 4, below 7, etc. And the number of students will not be frequency, it will definitely be cumulative frequency. But how do we know that? Well, first of all, they've mentioned construct a frequency table from the cumulative frequency table, so it's very obvious. Secondly, you also see that the number is increasing. And thirdly, when they say below 7, it includes all the students below 4. When you say below 13, it includes all the students of below 10, below 7, all of them. So it is definitely cumulative frequency. So how do we convert it into a frequency table? Well, like in the previous sum, we just subtract it. The first number copy as it is, 85, 85. In the question, however, you saw that the first number was 0, but there's no point in writing 0. So we can ignore it and start with the real values, 85, 85. In the question, the 0 simply means that there is not a single student below the age of 4. That's what it means. And how many students are there between the age 7 and 10? Including 7, but not including 10, of course. Well, that will be 140 minus 85, 55. What is this 140 a number of? Well, that is number of students below the age of 10. So below the age of 10, but out of that 85 are below the age of 7. So how many are left between 7 and 10? Obviously it's 140 minus 85. So that's how we get the frequency table, and the total is obviously 300. Next, Roman number 1 in the question is the number of students in the age group 10 to 13. That would be 103. Not 243. 243 is the total number of students below the age of 13. But I want particularly the students between the age of 10 and 13. That will be 103. So now you know the use of frequency vis-a-vis cumulative frequency. They give us different information. Roman number 2 was state the age group with the least number of students. Clearly it's 55, so the answer is 7 to 10 years. So make sure you write the units also in the answer. Next, the 12th sum. It's a tricky question because some frequencies are given, some cumulative frequencies are given, and we have to fill in the blanks. So it may be confusing if you are careless. You have to draw the whole table and underline the fill in the blanks. I have not underlined it, I have used the black pen. What I did is, first of all, when I saw CF as 15, I know the first number should always be copied. So there we go. Next, since the next CF is also given, what do we do to get the F from the CF? We always do 28 minus 15, which is 13. But I don't know the next CF. So how do I find the next CF? If you remember, we do a diagonal addition, 21 plus 28, which becomes 49. Similarly, 16 plus 49 gives us 65. Now again, frequency is missing, so 73 minus 65 gives you 8, and then 12 plus 73 gives you 85. So that's how you can complete this table. Now let's move on to exercise 18b, which has to be done only in a graph book. Cancel question 1 and 5.2, which are very easy and of the same type, so that way your homework will be reduced. There are four solved examples also in this exercise. Apart from that, you have to do these sums. I'm going to do sum number 2 and 4, then the rest is for homework. Fourth sum should be marked as IMP. Question 2. Draw a histogram. Histogram looks like buildings adjoining each other. And they've also asked us to draw a frequency polygon. So let's see how to do that. Since there are no calculations required in this sum, no need to copy the table. So on the theory part, just write the exercise number and question number if you want, and any theory calculation would be done on the RHS. On the LHS, you have to draw. Use pencil only for the theory part, calculation part, as well as for drawing a dark pencil but a pointed one. Make sure you always write the scale of x-axis and y-axis. 2 centimeter is equal to how many units or any other unit mentioned. Avoid using 1 centimeter graph because in the exams you always are required to use a 2 centimeter graph. So try to get that. So this is the y-axis here and this is the x-axis. Naming the axis is very important. So on the x-axis we will always have cumulative the class interval. Always is the class interval, remember that. On the other hand, on the y-axis we always have the frequency, which is what is mentioned here. Now if you look at the class intervals, in the question they have started directly from 10 to 20. 0 to 10 doesn't exist. Hence we have drawn a kink out here. So whenever you jump from 0 to some variable with no class interval in between, you can draw a kink to show the jump. Now for class interval 10 to 20, the frequency is 3. So my building's height is 3. No need to shade the building. Use ruler only. No, don't do freehand. Even the roof on top should be done with ruler only. Don't do it freehand at all. So the building is as a height of 3 units. Then 20 to 30 has a building of height 5 units, 6, 4 and 3 units. Notice how the buildings or the graphs, the bar graphs, are actually touching each other. That is why it is called a histogram. Next, they've asked us to draw a frequency polygon. So what we do, frequency polygon is this graph, the line graph. So we need to plot the points first of all. First, plot the points. What are these points? They are the class marks, the midpoint. So 10 to 20, what is the midpoint? 15. So that's where the point will be on the terrace of the building. On all the terraces, plot the points. And please go one box before the first building and one box after the last building as well. So here there will be a midpoint which will actually be 0 to 10. So midpoint is 5. And here the class mark is between 60 to 70, which will be 65. I don't want the frequency polygon floating in the air. It has to be grounded. It has to touch the x-axis. That is why I drew these extra points here. And then just join them with ruler only, not freehand. And that's how you solve this sum. But what if they ask you to draw the frequency polygon, that is only the graph part, without drawing the histogram, that is without the buildings? How to do that? So for that, look at sum number 4, it's IMP. Daily wages in rupees will serve as a class interval, and number of workers is definitely the frequency which we have to plot without drawing the histogram. Well, when we had the histogram, getting the points was easy. It's the midpoint of the box. But now that we are not drawing the histogram, it's better to write the class marks in a table. So here the table will be required to be drawn, to be written. Class mark is obviously the midpoint of these class limits, or you can say the average of these two. In this case, it's pretty easy. You can do it mentally as well. Otherwise, you would have to add this and divide by 2. 150, 200, 250, 300, 350. Notice how the interval between the class marks is 50, just like it is in the class intervals, a difference of 50. So now with this information, we can plot it. We have the scale here. Notice how the units are mentioned as rupees on the x-axis and number of workers in the y-axis. That is compulsory. We have the x-axis daily wages. The class interval started from 125 to 175, so there's a kink before that showing the jump, allowing the jump, and it lasts till 375. On the other hand, number of workers was maximum was 22, so I thought that I can take it as 2 centimeters as 2 workers each, so that the entire page can be filled. If I use 2 centimeters as 4, so it will become 4, 8, 12, 16, 20 and 24. So the graph will be only half the page, not the complete page, which is fine as long as it is neat. So you have to use your judgment to decide how much interval is to be taken. For example, if the highest number was not 22, what if it was 32? Then obviously we can't go by this scale, because we would never be able to plot 32 on such a limited graph paper. Make sure you write number of workers here. Give the titles to your graph to get full marks. Finally, we can plot the points. So the first point to be plotted is going to be 150, 4. Remember that. 150, 4. So 150 is somewhere in between 125 and 175, and 4. So this is the first point to be plotted. This way you plot all the points, but since I don't want it hanging, make sure it touches the x-axis on the previous box. Notice how the difference between the 2 points, the distance between the 2 points, the perpendicular distance is exactly 1 box, which is 2 centimeters. Even here, go beyond 375 and make it touch 400, which would be the midpoint of the next class interval, which is 375 to 425, which there's no need to write because it is not there in the question, but we need to join it to the x-axis for sure. So this was the sum. All the best.